Hello, my name is Matt Gamble and welcome to Game Dev Guide. In today's video, we're going to take a look at writing a localization tool in the Unity editor. You might be wondering what localization means or why you'd need to support it in your game. Let's take a quick look into it. Localization is the process of making something local in character or restricting it to a particular place. In the context of game development, this often relates to translating your game into different languages. In practice, it's often achieved by creating a system that supports swapping a placeholder or identifier text out with the correct localized value. So for instance, if you wanted to display the text frog, we might use an identifier or key, such as ID frog, and then depending on the language we're trying to support, we would swap that out for the translated or localized value of that key. Supporting this early in your pipeline is extremely useful, as most games rely heavily on text. Having to go back through all instances of text in your game and updating it to use a dynamic key instead of a preset fixed value is incredibly tedious and time consuming. So when starting a project and working with text, if you know you're working with multiple languages or may want to support other languages in the future, it'll save you a lot of time and effort to build a localization system into your project. I've built a localization system for my current game based around the demands we have for the project. I wanted to write a tool that makes it quick and easy to view, add, edit, and remove entries from within Unity. Okay, so first things first, we're going to need our CSV to read and write from. The idea is that we would have the keys and values in this file on each new line. There's a couple of ways we could approach the design. We could have a separate CSV for each language, but that requires maintenance when adding or removing keys should we need to work with multiple languages at once. So here, we're going to have a master sheet with all our translated values in one place, separated by a comma. Let's create a new file in Visual Studio, or your text editor of choice, and name it localization. Now, we'll quickly populate it with a couple of test keys and values and save it as a CSV file in the resources folder. Next, we'll create a new class called CSV Loader. This is going to be the class we use to interface directly with our data. We'll create a text asset variable called CSV file, which will be a reference to our file. Then, we'll define some variables for how to parse the sheet properly. We'll set the character for the line separator, and a character we use to define an entry. And finally, the separator we'll use for defining each value. We encapsulate it like this because we don't want the parser to break up text with commas in it. Now we'll write a function to load the CSV file and assign it. Then we want to write our parser function. In Engine, we'll be breaking the values up into each of their languages, so we want to pass an attribute ID which we'll define in the first line of our CSV. The plan here is to be able to call this function for each language we want, and the function will return a list for each value in that language. So, we'll create a dictionary to store our elements in. We'll break the text file up into its lines. Then, we get the ID headers we added to the top of our CSV, so our function can identify the location of each language value in our list. Again, this method allows us to add more languages easily by simply adding a new value to the end of each line and an identifier at the header of our file. Then we write this regular expression to define the parameters of splitting the line up, and we go through each line in the list, breaking the lines into fields and trimming off the quotation marks surrounding our values. We then make sure there's enough fields in the line, and if there is, we assign the first field in the line as the key and check if the dictionary already contains that key. If it doesn't, we assign the element at the attribute index as the value, and then add both of these to the dictionary, and then return the dictionary. Now we've set up a way to read the CSV, we can start working on the localization system itself. Let's create a new class called Localization. Then let's write a public enum and define a couple of languages. For now, we'll just use English and French. We'll also create a static reference to the current language and set it to English. Next, we'll create two dictionaries, one for our English values and one for our French values. With that set up, we need to write two functions, one for initializing all of the values and another for returning a localized value to a text element. So first, we'll make a new static boolean called isInit, then we'll write a function called init, and we'll use this to initialize our localization system and read the data from the CSV. Once the CSV is loaded, we simply assign the dictionary to each of our languages using their attribute IDs. So for English, it's EN, and for French, FR. And then set init to true to tell the system we've loaded the values. Finally, we'll write the getLocalizedValue function to return the value based on the key passed into the function. We'll tell the system to initialize if it hasn't already, and then set the correct value based on the currently selected language. And return it. And that's it. We now have a functional localization system. Well, almost. Part of the usefulness of the design of this system is how it will work automatically across your project. Ideally, we want all of the text elements in our project to display the correct localized value. So we'll need to write a quick script which will apply to any text element we want localized. Let's create a new mono behavior. I'm forcing it to require TextMesh Pro here because all of my text is SDF, but this would work fine with standard text rendering if you're still using that. So we set a string as the key, and then when the object is started, tell the text box to set itself to the localized value returned from the localization system based on the key. And so I've thrown together a number of different text boxes representing some values in the system, and as you can see, when we run the project, the text from the localization system displays accordingly. And if we swap the language over, it updates to show the selected language instead. So that's the basic framework for a localization system in your project. Hopefully you can see how flexible this can be and find it useful. This is just the tip of the iceberg though. In the next part, I'll go through expanding the system to allow us to edit, remove, and replace values inside of Unity, which means we'll also be able to write a couple of neat editor tools for easily navigating values, as well as a custom class we can use in our project specifically for localized text. If you've enjoyed this video, be sure to hit the like button and leave a comment. And of course, if you're interested in more game dev tips, tricks, and tutorials, be sure to subscribe. I'll see you next time. Thanks for watching.